Okay, hello everyone. Thank you for joining us for our Heat Smart presentation. Today we'll be focusing on Airsource, and we have our partner Dave Tierno, who will be going a little bit more in depth with his company, his offerings, and that'll come up a little bit later in the presentation. We are Heat Smart Southern Tier, which is a program of the Network for a Sustainable Tomorrow. And we have a variety of different clean energy programs. You might have heard of us from Southern Tier Solar Works or Binghamton Community Power. This is just one of our offerings that's basically here to talk about the incentives available to install heat pumps or energy efficiency measures. And yeah, so let's get started. Olivia, can you go to the next slide? Okay, so this is just a little bit more about our mission statement. So we're here as a nonprofit, which is a community-based network of programs working towards social, environmental, and economic justice and equity in our region. We cover the counties of Broome, Tioga, Shenango, Delaware, and sometimes Otsego counties. For our Heat Smart program, it is just Broome, Delaware, Shenango, and Tioga County. And now I will pass it over to our lead intern, Ellie, who will take you through some introductory slides, and then we'll hear from Dave.
All right. Hi, everybody. Thanks for joining us today. My name is Ellie Colton. I'm the lead energy intern here. Before we jump in, I'm just gonna go over a little overview of our program today. We're gonna talk about what is Heat Smart Southern Tier, why go Heat Smart. Then I'm gonna pass it over to Dave Tierno for information about Airsource heat pumps, the technology, the process, the incentives and financing, how to participate, and then we'll have some time for your questions at the end. So during our program, if you do have questions, feel free to put them in the chat, and we'll be keeping an eye on that and answering as we go. And then again, when we get to the Q&A at the end, we'll have time for that. So Olivia, if you could go to the next slide, please. We'll hop right in. All right. So Heat Smart Southern Tier, as we mentioned, is a NYSERDA funded community outreach program that connects you to local heating and cooling and energy efficiency experts who offer the latest clean energy technologies. We work to educate the public about sustainable heating and cooling systems through our workshops, webinars, and when it's not COVID, tabling events. As we mentioned, we operate in Broome, Tioga, Shenango, and Delaware counties. And just so you know, background, NYSERDA is the New York State Energy Research and Development Authority, and they support community-based initiatives like this. So if you could go to the next slide, please. The benefits of Heat Smart Southern Tier are reduced energy costs, home comfort and safety, you reduce your greenhouse gas emissions, and community awareness. So it kind of just leads to a more comfortable and healthier home. Next slide, please. Right now, 90% of New York households use fossil fuel for their home heating. This is just a little visual representation of other greenhouse gas sources. We've got transportation, but buildings, electricity, those kinds of things take up a lot of the percentage. So on the next slide, please, thanks. So our program covers weatherization and then 3 different kinds of heat pumps. We've got ground source, air source, and water heaters. And on the next slide, we can tell you about our competitively selected partners. So at Heat Smart Southern Tier, we're partnered with energy saving installers to actually implement these programs. Our partners are Airsource LLC, Daily Geothermal, The Insulation Man, and in Delaware County, we work with D&D Refrigeration. And all of these partners are competitively selected through NYSERDA. Next slide, please. All right, to talk about the heat pump technologies, I'm gonna turn it over to Dave Tierno over at Airsource LLC.
Hey, how's it going, everybody? Welcome, glad to have you here. First thing we're going to talk about is what exactly is a heat pump. Adam typically will ask anyone if they have a heat pump in their house, and most people say no. And of course, we tell them that, you know, they do have a heat pump in the refrigerator. Basically a heat pump just moves heat from one space to another using a refrigeration cycle. So all this graphic shows you is basically a compression condensation cycle where the compressor is squeezing the gas, which is adding heat to it. And then the heat goes through what's called the condenser, where the heat is removed from that refrigerant and put into the space of the house. Sorry, I'm getting some technical messages here. But anyway, once the heat is extracted from the refrigerant, it turns back to a liquid. It goes out to the evaporator, which is what you see on the blue side here. The evaporator, in this case of an Airsource heat pump, which is the outdoor unit. That liquid refrigerant absorbs heat from the air. As it absorbs heat, it turns into a gas. It boils basically the refrigerant, turns it into a gas, which absorbs the heat because of the low boiling temperature of the refrigerant, pulled into the compressor, so on and so forth. It gets sucked in, squeezed, increases the heat. It's just a cycle, hot, cold. It's a continuous cycle. So that's pretty much the basics of the refrigeration cycle and how it absorbs heat from the outside. It's all about the magic of the refrigerant boiling at a very low temperature. That liquid refrigerant boils at minus 55 degrees. So when it's 0 degrees outside, that outside air is still hot enough to boil the refrigerant, turning it into a gas, and thereby doing it absorbs that heat. The liquid phase to get to gaseous phase, as it evaporates, that evaporation is what absorbs the heat from the air, basically for free. So what you're paying for in this cycle is the energy of the compressor, basically. The compressor takes in that refrigerant that's absorbed the heat at no cost, but that heat energy is not the right temperature for us. It's not comfortable to us. So the compressor squeezes that gas, which increases it to 130 degrees, and that's how it heats the house. So you can go to the next slide, please, Olivia. Different types of heat pumps. We have ground source heat pumps. Ground source heat pumps are similar to air source heat pumps. They extract heat from the ground using glycol loops that absorb the heat. It's a little bit different, but the same general idea. A ground source is a much more involved, lot more moving parts, a lot bigger of an installation than an air source heat pump. It has an advantage of using the ground, which is a pretty steady temperature, where air source, the refrigeration technology has become very advanced because it's using air as a source of heat. And as you know, in upstate New York here, sometimes our air is 5, 10, 15 degrees below zero. So it takes a little more technology to extract heat from that type of temperature than it does, from the earth that's, 45, 52 degrees in there, depending on where we're at. And then a heat pump water heater is basically the same thing. It extracts heat from the air in the local vicinity of that water heater, which is your basement. And it uses the heat that's in the air it just transfers that into your domestic hot water. It's very efficient. And then it has the heat pump water heater does have an electric backup in case it can't keep up with the demand. It's not a really high recovery rate. It's very efficient, but it's not going to give you 10 gallons a minute of hot water. It's going to take a little while to recover. So, but that's the reason for the tank, is you have the reserve capacity, and they're very well insulated. So obviously energy efficiency is the primary concern there. So you can go to the next slide there. Okay, this is these are some pretty basic slides. These are not anything that we've installed. These are kind of generic slides, but you can see on the left, the outdoor unit. You can see the fan. What that fan does is it blows outside air across the heat exchanger coil. So bear in mind that heat exchanger coil in heat mode, that's an evaporator. There's liquid refrigerant in there. And as the outside air is pulled across that heat exchanger, that outside air boils that liquid refrigerant, turns it from a liquid to a gas. So you may have 10-degree air going into the back of that unit, but when the fan blows the air out, the air coming out is 0 degrees. So the air is dropped 10 degrees because that liquid refrigerant has absorbed the heat from the air. That's the magic of it. So the compressor then pulls that gas in, squeezes it, increases the temperature of it, and sends it into any one of these indoor units. The wall mount, most people are very familiar with, although that picture shows that unit mashed right up against a wall, which is not really a proper installation. It should have some clearance there, but there's a wall unit. They're very effective. They're very quiet. They're easy to service. They've been around for a long time. Mitsubishi's been doing this since the 70s, so this is nothing new. The ceiling cassette, that's something we do a lot of. There's a different style that fits in between ceiling joists. This one here is typically more of a light commercial application that's meant for a suspended ceiling. There should be an access panel next to it. They're not really designed to be serviced from below, but they are an option on a second floor. They can blow air in 4 different directions. The floor mount or a low wall mount, that's an option when there's no space high on the wall. And then the mini duct, that actually goes up typically above a ceiling. You can put them below a floor. I'm not a big fan of ductwork in the floor, but that's basically an air handler with a heat exchanger coil in it, and it allows you to catch 3 or 4 or more different rooms in one zone, which for technical reasons during design, there's a lot of times when you're doing an upstairs, it makes much more sense from an efficiency standpoint and a cost standpoint to put in a mini duct or a ceiling concealed unit, because the load may only be, say 12,000 BTUs, and you have 3 or 4 rooms to split it amongst. So when you start to put a wall unit or a floor mount or ceiling cassette in 4 different rooms, you've just added 4 zones to a system, and that's a really big expense. And the other thing is that the equipment, design is it's a little involved, but you really want to spread that load out amongst multiple zones instead of, you don't want to design around zones. You want to design around what the load is. So those mini duct units are very effective in handling, that one load and spreading out between multiple rooms. And allowing the unit to run more efficiently. And it's a really good application in a lot of cases. We do mostly whole house work, probably 80%, I would say, are whole house heat pump projects. And we use those, and probably 50% of the whole house projects we do get one of those typical ceiling concealed mini duct units. So you can go to the next slide. Benefits, energy savings. Their COPs are very high, depending on outdoor conditions. At 10 below 0, the COP is not as high as a geothermal system. It's just not. But that's such a small percentage of time. The big benefit, obviously, is that you don't need a distribution system. You don't need, thanks for the note, Adam. Yes, coefficient of performance. It's basically an expression of energy in versus energy out. So you want to see anything more than one. One unit of electricity, how many units of heat are you getting? The higher the number, the higher the efficiency. So energy savings, that's pretty obvious. You're using the advantage of the refrigeration cycle to do the work, collect the heat at a very low cost. The distribution system, back to that, you don't need radiant in the floor. You don't need high output baseboard. You don't need panel radiators. You don't need duct work. You don't need anything. So we just finished a big job yesterday. That was the house was built. And we do a lot of these built in the 80s, late 70s, electric heat. Some of them have the thermal storage unit. Some are electric baseboard. But the house is finished. This was three levels of finished house, and trying to put duct work in there. There's no way to put a geothermal system in there. You just can't do it. It would be just very, very invasive. It's just not really a feasible option. But we can go in there effectively and easily zone the entire house with ductless system. So there was no space in that particular project to use a mini ducted unit. But we figured out a good way to break it up with multiple units, the way you approach it, to make it work very effectively. But that's just one of the benefits, is it's so versatile. You know, you can apply it to pretty much any style of home or project. It's air conditioning and heat without the ductwork, and all of the things that go along with ductwork. You know, the noisy blowers and the dirt and dust collecting in ducts that are located in the floor, unsealed ductwork, uninsulated ductwork, all the performance issues, and the inability to zone typically, which we'll talk a little bit more about. Full heating replacement not required. So you can do, you can do a portion, of the house, a room that's cold, which my first recommendation is always figure out why the room is cold rather than just spend money on heating equipment. Let's, not spend money to make heat, first spend money to hold on to the heat you have, make the house more efficient. That minimizes your cost on putting equipment in. You really want to treat the house first before you think about, adding heat to it. Air sealing and insulation is paramount. So back to the slide here, you can do partial. You don't need to do a full heating. And typically we tell the customers, you have a functioning system. If it's an existing house, new construction, we're the only, we are the only source of heating and cooling in the house. But in an existing home, we always leave the existing there, since it's functioning. Okay. So it's flexible and you can zone it. They're extremely quiet. You don't have to have the whole house be the same temperature. You can have individual zones. You can have a 68 in the bedroom, 73 in the living room. Looks like I'm getting a little short on time. I can't stop talking about heat pumps. Next slide, please. That's, I guess I'm supposed to talk a little bit about the company. I'll keep it very brief. I've been doing this for about 10 years or so, got very interested in it, started a company and specialized in it. And I try to know everything and anything there is to know about this technology so that I can apply it most effectively and, just be the best at what we do. That's our goal. We try to work better and have better workmanship, craftsmanship, better designs. We think about every single little detail when it comes to that, and it does separate us from other companies that try to do the same thing. Next slide. A little overview of how a project is executed. Starts with a phone call or an email. Hey, we're thinking about doing this or doing that. So we just talk about the house. We talk about what would you like to do? What are your goals? So we get that information. I figure a little bit, talk to them about the house, when it was built. Have you done any modifications to the insulation system? Do you have NYSERDA or a municipal electric or a co-op? There are some very, very good incentives, but they're not available to people with municipal electric or that are part of a co-op. So that's something that we cover. If it sounds like it is a good application and they're interested, I come out, do an assessment of the house, and we talk about, this is what we do all day, every day. So I have a pretty good idea of what things are going to cost when I look at the house. I can't give a firm proposal until I do a load calculation and know for sure what the load is and get a firm design. But we will give a ballpark, and if it's something that they definitely want to consider, then we'll go ahead and measure the house and get the information needed for the load calculation, and then we'll go from there. Then we start the design. You can go to the next slide. So we'll design the system based on all the particulars of the house, the customer's preferences, types of distribution. Just we take every variable into account. And then, of course, the design is mostly based on the output required. The load calculation, that's what we do to get the amount of BTUs we need the system to provide at our chosen design temperature. The homeowner makes a decision if it's something that they want to proceed with, and then if they do, then we just schedule the work and we execute the work. I average between 4 and 8 weeks. Sometimes it's less, sometimes it's more, depends on different variables, but that's a pretty good ballpark there. And then once the system is designed, I spend time personally with the customer explaining to them operation of the system, how to get the most out of it, what to expect from a performance and maintenance standpoint, all the little details. And I also have some documentation, about 4 pages that I give to the customer that has good information that's not in the manual, just things that I've acquired over my 10 years of experience with the systems. Of course, I have them in my house, and I observe mine and my customers, every day. So I have a pretty good understanding of what to expect and how they function, of course. So. Oh, you can see it left-hand side, -6 degrees, outdoor dry bulb, and 6.5 degrees. That's an Albany area design temperature. But you can see here we have a mini duct for one zone. Below that, there's a ceiling cassette for the kitchen dining area. There's a wall unit in the great room. There's a ducted unit for the master, which catches the master, 2 big closets, and the master bathroom. So there's 4 or so runs off of that particular ducted unit. And then there's a wall unit for the foyer. And you can see, I can look at each zone. I can see how many BTUs it's providing. I can look at the discharge, air discharge temperature at 6 degrees below zero. It's going to make 90-degree air, 93-degree air, so on and so forth. So that's basically, we use that. You can see the output on the top there. We reconcile that against the load calculation, and that's the correct way to design to ensure that you're going to meet the output required when it is, at design temperature, peak load. Next slide. Oh, these are just some quick pictures. This is a very simple, very straightforward single zone application in a living room. Someone that was looking for mostly cooling, but after some discussion, really wanted the benefits of, and I always encourage this, put in a low, a cold climate air source heat pump, and they absolutely love it, and actually had me do one in another part of their house. But that's just a basic, outdoor installation. Next slide. That's the corresponding wall unit for that. That's just their highly featured indoor unit above the window there. Go ahead. This is a whole house job. It was a 5, I think, I can't remember how many zones, 4 zones, 8 zones, I think, 5 on one, 2 on the other, in a log cabin there. That's, that was the main driver there, was sustainability, but yeah, that's a whole house, kind of a typical of a, mid-sized job there. That is the branch box on that job. So what that basically is we talked a little bit about zoning. Each one of those branches, each set of pipes there goes to a corresponding indoor unit. And each set of those pipes has their own individual metering valve inside that box that sends the appropriate amount of heating or cooling to each zone. It's basically, that's the parts of the system. You saw the outdoor unit. This is the branch box. And then that branch box is connected to any number of indoor units. So those are basically the major components of the system. And those black pipes coming in the bottom is where the outdoor unit feeds the bulk heating and cooling to the branch box to be distributed throughout the house to the other zones there. And it's just yeah, you can see, I mean, we put a lot of time into our workmanship. It doesn't matter what the house looks like. If it could be the nastiest crawl space you could ever see. but it doesn't matter. We do our work the same. It doesn't matter if it's a new house or a house like, it all deserves, the highest level of workmanship that we can provide. Next slide. That's another outdoor unit that collects the heat. That's right up behind the Binghamton University. Next slide. Another branch box, that's to the one you just saw there. That's a 4-zone system that was paired with a single zone on the other end of the house. And that did have a ducted unit connected to it for 3 upstairs bedrooms. Next slide. That's a close-up of a ceiling cassette, the one that fits between the floor joists. So that's actually on the first floor of a 2-story house. Next slide. Oh, it's another ceiling cassette. That's in a ranch. Next slide. That's a wall unit that we did in McGraw. That's a pretty typical application there. Next slide. Another wall unit, same house, just to give you an idea of how it kind of fits in. A lot of people are concerned with the appearance of them, but I mean, usually within the first week, people just forget they're there. It just keeps them comfortable. Next. That's a ducted unit that we were fortunate enough to be able to put in after the insulation man put about 14 inches of cellulose in that attic. So we had our snow shovels out, and but you can see when we're done, we smooth out, we put everything back like it's brand new. We seal. We're very careful about what we do in attics as far as making sure the insulation is intact, and it's as good or better as when we found it in most cases. But that's basically an air handler. You can see the level of insulation because it is an unconditioned attic. It has to be insulated very aggressively. And each one of those goes to, I think there's 3 bedrooms and a bathroom off of that air handler. You can see the refrigerant pipes that feed that particular. Okay. That's a picture of a deep energy retrofit where we paired up with the insulation man. It's a barn converted to a house. Really interesting project. Had the walls open, put lines in the walls, so on and so forth. So that's kind of typical project for something like that. We do all kinds of different projects, and we can put these systems in pretty much anything. You can go ahead. Yep. So these are just the incentive levels, basically for, I'll do the Airsource stuff. It comes down to if it's a partial load or a full load. So if we're doing something in part of a house, it's $500 per outdoor unit. If we're doing the whole house job, which is typically what we do, then it's $1,000 for every 10,000 BTUs of heat that the system makes at 5 degrees Fahrenheit. So the system we looked at, that design earlier, that system makes 5,400 or 54,000 BTUs at 5 degrees. So that incentive for that unit was $5,400, and that comes off right off the top. So it's not money that has to be put out and comes back in a rebate. It's money that comes directly off the cost of the project. So if someone wants to talk about the rest of I mean, I don't know, that it's not really applicable. This is an Airsource event, so I don't think we need to cover the other incentives. NYSERDA does have financing available, smart energy loan and on-bill recovery. Those are the 2 main styles. Typically, the smart energy loan is what most people do, up to $25,000 for 5, 10, or 15 years. It's usually 3.49. That's if you use auto pay, or 6.99 interest. No penalty for early payoff. You apply online. It's a bit of a process, but it's definitely worth it. It's a really good loan. We do a lot of the Green Jobs, Green New York loans through NYSERDA and EFS. This is something new. I'm not going to talk a whole lot about it, other than the fact that an Airsource heat pump system is now eligible for some additional grant money through assisted home performance. It's in the infant stage, but I am going to look at one of these projects later today. It's just something. You might qualify for some extra grant money depending on income levels and so on and so forth. An Airsource heat pump is part of it's considered now an eligible measure, meaning that this grant money through assisted home performance can and will apply toward your air source heat pump system. And I think that's a limit of $10,000. So we have some details to work out on that, but it is something that if you're considering, you definitely should look into it, when you're doing your work with your weatherization work, and you're considering air source, you should definitely talk to them about a heat pump system and assisted home performance and how the two might work together. Next. This is, I think, goes into this is Empower, which is another grant based. This is something I think that would be discussed during your audit. We're not going to go into it a whole bunch now with specifics. That's something you can go over with the energy auditor or with myself in person. Again, this is more information regarding additional incentives that are available. Process for participating, basically sign up for an assessment. Usually it's a good idea to call the installation company first and let them get a handle on what you might have for low-hanging fruit as far as improvements to be made. Air sealing and insulating, maybe work in the attic or on the rim joist are two pretty typical. Seal high, seal low, and insulate where you can. That's a good idea. You know, they'll go through, look at your house, look at your combustion appliances, so on and so forth. Which another benefit of Airsource is there is no combustion. That wasn't on that slide, but that's a very good benefit to it is from a safety standpoint. So you basically sign up. You can find all this information on the Heat Smart website. Sign up for an assessment. They'll come out, and then you can they'll point you to the Airsource, or you can give me a call and we'll come out and do that. It's good to always start with an assessment through the energy efficiency people, the installation man. You'll get a quote, decide if you want to sign. Basically, they'll give you a quote. This is for an overall. This is designed for basically the assessment from the installation company. But basically, you'll get a quote, decide if you want to sign, and then apply for incentives or financing and complete the installation work depending on what part you might do installation, you might do air source, you might do both, but that applies to either or. So you can go ahead. Questions? Any questions?
Yeah, so for questions, if you want to either put your question in the chat or you can just put the word question and we'll unmute you. Don't be shy.
Any questions about if they might work for you or anything you've wondered about them? Do they, they do work? We've got customers that, 22 degrees below zero and they still heat their house with air source heat pumps. Any information that you're looking for, we're happy to give you.
Dave, until we get a question, maybe you could say a little bit more about that deep retrofit case. Just be interested to know, what is it you found and what was it like working together with the installation man? How did you make that work?
Yeah, it was an interesting project. We love doing new things, different things that may intimidate a little bit. Some other, but it was very interesting. It's a barn, so you got to think there's all kinds of passageways and bypasses for feed and different. I mean, the construction is interesting, right? Because it's big post and beam stuff. So it was kind of neat to see that project was actually started years ago by Pat Dundon who's an icon in, as far as I'm concerned, in the energy efficiency sector. And he did some really interesting things there. And this stage of the project, they were actually pulled the walls off, and the insulation man spray foamed to minimize the air infiltration they were getting there, because of, as you can imagine, an old barn with fiberglass insulation, there's going to be a rodent issue after a while. So they did, they mitigated a lot of that. It was the working with them was, I mean, they're a great company. So good communication. It was easy to schedule things. I mean, the walls get open and we put our lines in.
Hey, Dave, your sound just cut out for a second there. Yep, still can't hear you.
But
now you're back. We lost what you said up till that point.
Oh, I was getting a phone call. Sorry about that. I'm using my phone for audio. But yeah, it was a good, interesting project. It was, I think, 6 zones, 5 zones on one multi-zone outdoor unit, and then another single zone for the studio. They did spray foam the studio as well. The customers, I mean, it's just money spent on insulation is just, it's just a good investment. And once you do that, it minimizes the amount of equipment that you have to purchase, from an Airsource side. Minimize the load. It makes your initial investment smaller and makes your operating cost less when you do the air sealing and the insulation. So.
So I'll also say this is a good opportunity if you have any questions to ask regarding financing. We just talked about that very briefly, but we can say more about that. Those latter slides are mostly referring to income eligible programs. And actually, Olivia, if you could bring up the assisted home performance slide for just a second. The assisted home performance program has a temporary feature in that normally the income level, go forward. There's what we want right there. Yeah. So as you can see, eligibility is expanded up to 120% of very immediate income through December 31st. So these income levels that you see here are considerably higher than they normally are. And so if you think you might qualify for this, it'd be good to get started sooner rather than later. One thing to know that with NYSERDA incentives, as well as tax incentives, which aren't relevant in this case, but are for ground source, as long as you have signed a contract and your installer has applied for the incentive prior to the deadline when that expires, you're still good. So if you're not in a position to actually start installation before the end of the year, you could still lock in that benefit.
Adam, looks like we have a good question regarding new construction. So let me just finish reading those. Okay, so new construction resources, basically the way that process works out is you start with the plans. Email the plans over. Plans are, it's easier to do a load calculation on a new build than it is on an existing, because you're working with known insulation systems and infiltration rates. I mean, it's a lot more simple. It just starts with that. Send the plans over. That gives us the load calculation, and then we go ahead and design the system. Talk about what kind of distribution you might want in there, ceiling cassettes versus wall units versus possibly ducted units. Depending on what makes sense from the structure standpoint. The ground source versus air source. I mean, I'm a proponent of ground source. Our ground source partner does a great job. Obviously, I do like I mean, I prefer air source, but that's the advantage of the air source is that you do have much more versatile. It's just more versatile. You don't have to duct your whole house. You don't have to, I mean, a duct system is typically in a new build with ground source, you would be doing either a ducted system or you'd be doing radiant, but then you need to put an air handler or air handlers in for the cooling side. And they're much large. They're just larger. You know, they use water instead of refrigerant. It's a little bit different. So the advantage of the air source versus ground source is that you don't need to drill wells or dig trenches. You know, it's using heat that's already in the air, which is of course beneficial. You can have zone the house. So you can have 5, 6, 8 different zones. You know, you can have individual temperature control for each zone. Looks like I lost my video there or whatever, but in the cost, I mean, I know there is some really good incentives for ground source also, but typically an air source is I would think a little less costly than a ground source, although there's a lot of variables that play on ground source. So you don't, you know, it's hard to determine if it's water to water, water to air. I'm sure there's a big cost difference, but if you're really interested, you know, talk to both. You know, we'll talk to you about air source, and you can talk to our geo partner. They're excellent about ground source, and whichever one fits better. You know, for you, you know, that's what you'd want to do. But yeah, I just think we're probably a little more versatile and can give you a better temperature control and so on and so forth.
Speaking of temperature control, Mike Kane has a question. How is temperature regulated in each room? Is it similar to a conventional thermostat or what?
That's a good question. The way it works is each unit has its own individual thermistor. So each unit, they come with a remote control. The remote control does not sense temperature. The unit senses temperature. So basically you just tell it, hey, I want it 72 degrees, and the unit modulates up and down. So you have each zone is constantly, it's like cruise control. It's constantly giving you more or less heat or cooling based on the set point that you've chosen. Now there are enhancements to the remote control. There are wireless thermostats that are like a conventional wall thermostat. The unit functions the same, but it allows you to use the temperature sensing point from across the room on the other side. In other words, with just the remote control, the unit is sensing temperature from the location on the wall. If the room is 30 feet long, then as you can imagine, the room is going to warm up near the unit faster than it's going to warm up on the other side. So you can use a remote thermostat. And I typically install at least one of these on a whole house job. You can put that on the other end of the room, and that will give you a more constant, continuous output and more comfort. You still got me on audio, right? Because I lost the page.
Yeah, we can hear you loud and clear. We're missing your pretty face, but we're getting the content.
You're not missing much there. That's one thing I love about these masks is the more I cover my face, the better I look. I think I'm joining back on, but that's a really good question. You have individual control via remote or via thermostat of your choosing. There's also an app, Wi-Fi app you can put on your phone, so you can actually control. You can actually control the entire system with your phone. So that's not a necessity by any stretch. It's a convenience and should be used only as such. Good question. Both of them really good questions. And can you guys put my email up there in case Suni wants to email me some drawings to look at and give her an idea?
Yep. I'll put that up in just a second. So I guess one thing that I might suggest to our guests, you know, you could essentially state your problem what is it that motivated you to get on this webinar? What are you looking to solve? What's going on in your home right now? This is a good opportunity to ask a question like that, if you would like.
Also, from a new construction standpoint, we have several projects out there that we've done, and our customers are always offering to have people that are looking at doing it talk to them, go see their project, so that they can see firsthand what it looks like. They can talk to them about their experience. That's always an option too if you're having trouble deciding between which system is right for you. But what Adam said is absolutely correct. Figure out, what is it? What's your motivation? Some people, we've done whole house systems in houses in Binghamton that had natural gas, and the motivation there was sustainability. They had a fully functioning natural gas system that was pretty low cost, but they wanted low carbon, and they get their power from the solar farm, and that's a great way to apply Airsource.
Actually, since you raised that, I did want to bring to the attention of our guests some important policy information that might affect decision making if you're looking at the long term. Currently, the price of natural gas is considerably lower than delivered fuels like oil or propane or kerosene. But because of the fact that methane, which is the main ingredient in natural gas, is a very potent greenhouse gas, and because the life cycle of gas production and distribution and use releases a great deal of that through leaks, and because of the safety and health issues related to natural gas, New York State is engaged in a planning process whereby we're going to be progressively decommissioning the natural gas system. Now that's going to take like 4 decades to go through. But the reality is that the low prices that exist now are very, very artificial. Just to give you an example of what I mean by that, if you want to put in a natural gas service in a new construction home and you're 100 feet from the main pipe, NYSEG will come in and connect you up for nothing, but it doesn't cost them nothing. It costs them about 25 grand, and all ratepayers pay that. Whereas if you want to get a geothermal or an air source system installed, right now that financing is on you. That's not going to continue much longer. So, when you're thinking especially about new construction, but also, a home for the long haul, it's a good idea from an economic perspective to also do that, in addition to the fact that these systems are really better at heating, and let's not forget cooling, right? The cooling for air source and ground source is way, way, way more efficient and cheaper than conventional window air units or conventional centralized air conditioning. So that's a benefit that is of increasing relevance as it gets warmer.
Yeah, for sure. And the dehumidification is amazing as well. You can't get it as comfortable. I mean, the air source, they modulate and they're always cooling and dehumidifying. It's the most comfortable AC for sure. Judith has a good comment here. When living in Germany, I had an air source heat pump, but it was a big unit in the basement, which had a water heater in it as well. That meant we didn't need the fans outside, which is an aesthetic issue. So you can't, an air source heat pump that's heating your house can't be put in a basement or an enclosed space because it needs a huge amount of fresh air to extract heat from. So what would happen is if you put an air source heat pump in your basement to heat your house with, it would extract all the heat out of the basement in a short order. And it would essentially turn your basement. It would continue to get colder and colder and colder until it would be 20, 30 below zero down there, and it would make this system work harder and harder. There's very specific clearances around the unit that to where it needs. Oh, we had pipes through the basement window, so you did have something outside. That would be where it was collecting the heat from. This is just an all-in-one integrated evaporator outside that absorbs the heat. I mean, from aesthetics, there's a constituent of mine that lives downstate he believes solely in single zone heat pumps, 1-to-1s. So if there's 12 zones, he'll put 12 outdoor units outside the house, which to me is excessive. I mean, I think there's an ideal solution for every house using an air source heat pump, and individual single zones are not it, in my personal opinion. I mean, just from an aesthetic standpoint, having all those, I mean, the multi-zone, at least it's just one. And look, you can put it, I mean, you usually put it on a gable end of a house somewhere out of, it's not on the front of the house. First of all, they're quiet. You can put, you can put a fence, a picket fence or something around it. I mean, those are all, all things that can be dealt with. Air to air source or air to water source, which is best? Okay, so we don't have that's a good question. We don't have a big access to air to water air source equipment yet. I am in discussions with Mitsubishi about this particular subject. They do make equipment that's air to water. It's great for radiant applications and so on and so forth. I mean, ideally, you'd be able to use air to water for radiant floor and still have air to air so that you didn't have to deal with the struggles of cooling. If you could get air to water and air to air out of the same system, that'd be ideal. And I'm sure it will down the road, but I mean, it's just like trying to cool. Geo, you definitely can do cooling. You can put duct work in or air handlers, low wall, high wall. They're not as slick as the air source. They're a little more, it's not a detriment. I'm just being factual. They're just a little more clunky than the air to air stuff. What the idea is to get it to where it's really slick on both sides. Which is best. It depends on the application. I mean, that's everything is situational. There's not one that's better than the others. Air to air better or air to water better. I mean, if you have a slab on grade house and you definitely want radiant heat, then air to water would be better, because now you can keep your slab 80 degrees using air source in that application. But in an application where you have a conventional 2-story house, and you don't have any access, you don't have any low temperature radiant system in your house, then air to air would be better. So it really does depend on your particular situation. And that's why the assessment is important, so that we can look at your particular house and see what's right for you.
So we've got time for 1 or 2 more questions.
Very good questions. But back to the one with the basement, that's interesting. Basically, it was a split system. It's kind of probably similar to central air, where you have a unit outside and a unit inside. And so that would be, I mean, the pipes that went through the window would have connected to an evaporator outside, which collected the heat. So it essentially is the same thing. It's just not in a box may not be in the similar box with a fan on it, but the pipes going outside were going out there, to collect the heat from the air. You can put an air source heat pump in a commercial setting, in a basement, in a warehouse. They're typically used where you have huge amounts of air. You can, in those situations, put them inside. But typically in a residential application, no, there's not an opportunity to do that. It just would turn the house into an ice box in the basement. Nothing outside. The pipes were purely delivering air or pushing air back out into the big unit. Oh, okay. So the compressor, the evaporator was in the basement. It just used those big pipes to move the inside air in there to pull the heat out of it, and then push the heat outside, or push the cold air outside. I totally get it. I've never seen a system like that here in the United States. There are things in Europe that we don't have here, including the air to water heat pump that Mitsubishi makes called the EcoDan. But yeah, that's really interesting. So basically, in this case, whole house, if you're looking at 5,000 CFM, you'd have to find a way to collect, that amount of air. I mean, it would be tremendous, huge duct work, not something that's really feasible. For a water heater, yes, you could probably do that. And that's probably what that was for domestic, mostly for domestic hot water. But in any case, yeah, what they're doing is just keeping the equipment inside and just taking warm air or air that has not had heat extracted from it from the outside, ducting it through this big unit in your basement, sucking the heat out of it and blowing that air back outside. Same principle, just doing it inside the house. It's pretty interesting.
All right. Well, we are just about at time. And oh yes, radiant heat. Is that something that radiant heat with Airsource?
Yeah, so you can do that. But like I said, right now, I think you can get it in Canada, the EcoDan. It's not available to the US now, and we've been pushing them because I've got high efficiency houses with radiant heat in the basement where, I'm putting in mini, very low load houses, and we're putting in mini electric boilers because it's it's no different than, it's actually less than propane. And oil, it's about $2.80 a gallon. It equates to, depending on efficiencies. But an electric boiler, when I could be using an air to water heat pump, or someone putting radiant, new construction with radiant heat, air to water, and then to be able to use the air to air off that too would be ideal. But yeah, no, it's air to water. Airsource heat pumps is definitely prevalent, and it's used quite a bit in Europe and should be available here. I hope it is soon.
So on that note, I just want to make one comment before we close, or two, before we close the webinar. Thank you all for joining, and thanks so much, Dave, for taking the time. Dave is always out on a job site. He has to find good places to connect. And so a reminder, yes, if you are interested in signing up for an assessment with Dave or with any of our partners, nynest.org is the place for that. I also want to mention that, really the reason why there is wider deployment of these wonderful technologies and more variety available in other countries has to do with policy. It's not to do with technology. And the more people that adopt these systems here, but also make some noise. I actually have a meeting with some folks from the Industrial Development Agency and the Chamber and others. And, I'm hoping we're going to see more folks in leadership, both elected officials, business leaders, and so forth, being champions for this sort of technology. Because really the areas and the countries and the cities and the regions that get on board soonest are going to be the ones that not only benefit from these technologies in terms of building owners, but there's also jobs to be considered. And this is a massive growth area, but the pace of growth in jobs is somewhat localized, especially with energy efficiency and heat pumps, because obviously those are very local technologies. You put them into buildings, or, at most you can have district geothermal systems or so forth, but it's still something that's right there where you are. So I would encourage all of you, to the degree that you can, in your own circles, to encourage folks to, join our webinars and to, make some noise with elected officials and others in your circle to encourage them to consider these technologies and to promote and make them easier for folks to adopt. So thanks again, and hopefully some of you will join us on the 18th. Dave will be back with his colleagues from the Insulation Man and Daily Geothermal, and we'll sort of do a general webinar. Have a great afternoon, everyone.
Thanks everyone for your time.